Hello, my name is Ken Irvine from the IHE Delft Institute for Water Education. And in this section of the fundamentals part of the course, we will consider management of freshwater ecosystems. And when we talk about management, we need to consider governance. Both are extremely large topics, but here we will provide an introduction bearing in mind the point of view of the practitioner, or what we sometimes broadly refer to as the water manager. But as we shall see, the management of freshwaters involves a very large array of potential stakeholders, and for which technical expertise is only one, albeit a vital component. In the next two sessions, we are going to provide an overview of management and governance. Each video is about 15 minutes long, and this will also provide a natural break when following the two. The learning objectives for the combined sessions are: firstly, appreciate the need for water policy and its links with water management. Secondly, to identify core components of management and the management cycle. Thirdly, to list different types of knowledge for effective water management. Then to identify the link between management, governance, and citizen involvement. And finally, to consider future challenges of integrated water management. Along the way, we will touch on many other topics, and we will try to bring a more holistic view to the sessions. Okay, so first, in video 1, let's consider management and policy. We can also think about what do we mean by water policy. Policy provides the goals and targets for water management. We can view it as where we want to get to, and management as the means to achieve that. Achieving policy objectives requires actions, and actions requires goals, and the measurements to check and verify if those goals are being reached. A management goal might be a hard and fast, even legally binding target, or it can be more aspirational in order to move towards a goal. Policy instruments can be created to provide incentives, such as financial subsidies or discounts, in reaching those goals, or through penalties, sanctions, fines, even imprisonment if the policy is within criminal legislation. The use and balance of these instruments varies depending on what is the relevant and documented policy. Therefore, the wording of such policies become a critical factor in attaining and documenting the success of environmental objectives. Policy guides and underpin management. So policies and management objectives hardly, maybe never, arise without a recognized problem. Usually it is a case of there's a problem, something needs to be done. In the slide is an illustration of gross river pollution and the clear implications of the health hazard that provides. Any policies to protect this river, the Bagmati River that runs through Kathmandu, have clearly, up until now, not been effective. So we need to ask the question, which problems can be managed? The need for management arises when there are conflicts in the use of resources, and where there are interests and motivations among those who wish to use those resources. Human choices lead to different results, resulting from decisions by actors who are mandated to make those choices. And prevailing norms provide a basis on which to judge the value of those decisions. And the management of one problem can lead to other problems arising. We often consider that as issues of wicked problems. Let's build a picture from relatively straightforward to extremely complex. To do that, let's consider firstly some classic cases in the history of water management and ecosystem health. We start with the Great Stink of London of the 19th century, where the pollution of the River Thames and the tributaries to the river led to gross public health risk and hazards for the citizens of the city. When there's a problem, it motivates a solution, and in the early days this motivated engineering solutions by putting the tributaries underground, separating the source of the pollution from the access by the citizens. That later led to the building of the sewer system within London and the increasing use of sanitation facilities in order to address that public health hazard. Other major events in the history of water management that caught the public and political attention include the typhoid deaths in the US water system caused by the US water supply, which was solved by a very simple solution of chlorinating public water supply. In the 1950s, a fire on a river, the river actually ignited fire, stimulated public attention and a demand for action to reduce the worst excesses of water pollution. And even in 1986, a fire in a storage depot used for pesticides and highly dangerous agricultural chemicals led to a spill that turned the River Rhine red, providing impetus to policies which were developing at the time, including the International Commission for the Protection of the Rhine. These are three examples where fairly extreme events, death from contaminated water, the river igniting, and visible pollution throughout the whole of the largest river in northwest Europe, prompted political and civic response. So when we think about what is the response, the public policy response to such events, and how those events highlight a broader and perhaps less visible problem, we can think about public policy as being there to solve perceived problems. And those perceived problems are based on the evidence that is available at the time. So policy emerges from objective issues identified by observations and research. Public and political agendas shape that policy with inputs from a variety of interest groups, whether they be business or civic. And these political objectives and scientific identifications of the problem identify where there may be technical alternatives, technical solutions, and where there may be political objectives in order to combine to provide a meaningful policy to reduce the problem. And these issues interact and involve numerous stakeholders. And we often talk about policy as being a messy process because of that. So for all policies, and hence management and its actions, the scale of action, the scale of management is of utmost importance. And scales can range from very local, for example, bylaws, to international or global agreements. At each tier, there will be different actors involved. Connecting the tiers brings added challenges. If the catchment is the basic unit for freshwater management, then connecting those tiers of management and the governance that goes with that is essential for success in dealing with water pollution and with ecosystem health. And these scales are nested within each other. So the local scale is nested within the wider district scale, or national scale, regional scale, and up to global scales. So to better grasp what we mean by policy, let's consider the definition of public policy. This definition is broken here into a number of bullet points in order to highlight different components. And in bold, we have added some keywords which are essential and which are connected. So the formal definition of public policy is a purposeful and consistent course of action that is adopted to achieve objectives which are produced as a response to the perceived problem of a constituency, formulated in a specific political process and adopted, implemented and enforced by a public agency. The last two bullet points are often where practitioners find themselves involved in the process of the creation and the implementation of policy, leading to its development and indeed how is that policy transferred into management systems. So as this whole course is about freshwater health, it is useful to connect that with the concept of policies and management actions that support and promote that ecosystem health. We can start with a definition of ecosystem health as a measure of the stability and sustainability of ecosystem functioning or ecosystem services that depend on an ecosystem being active and maintaining its organization, autonomy, and resilience over time. Ecosystem health contributes to human well-being through sustainable ecosystem services and the conditions for human health. There's some really notable terms in that definition which relate to the fundamental ecological state and functioning of an ecosystem and its organization and resilience. So there have been many examples globally of using that ecosystem health concept, or in this case ecological condition, in order to identify the state of the ecosystem in question. This example comes from the South African river classification system, and it divides rivers into 4 categories of natural, good, fair, or poor, based on the flow regime as one component and the ecological condition that is commensurate with that flow regime. So a natural condition would be expected to have negligible modification of the in-stream and riparian habitats and biota. At the other end of the scale, a largely modified river, a largely modified flow, would be expected to have a reduced habitat diversity and a complement of species that would be adapted and suitable to that sort of disturbed system. So thinking about the descriptors of an ecosystem, not only about flow, but more general, it would be possible to have a view of the ecological condition or state shown in each of these slides. It might be a reasonable guess that picture A represents a natural free-flowing river in spate during high flows. But it could also be that this picture was taken just after release of water from an upstream reservoir. Picture B could be seen as a polluted river, but maybe it's a tidal stretch of water showing exposed riverbanks and muddy water from tidal disturbance. Picture C could be the result of long periods of low water because of water abstraction that has allowed the establishment of that vegetation in the river. Alternatively, it could be that this river is in a geographical regime, geographical zone, where periodically very high flows re-establish the state of the river, and this represents natural regeneration of vegetation in between those extreme events. And picture D looks like a heavily modified water body that has been a channelized river. The water quality doesn't look so good. But if you look to the left-hand side of that picture, you will see people fishing. So maybe the ecological state isn't as bad as we may at first consider. So ecosystem management sits within a policy framework. And those frameworks, although there are different examples of them, they share some common properties. A generalized process for management development and implementation is shown in the slide. You can study this yourself in more detail and follow the link shown at the bottom. But in essence, and the thing to bear in mind, is that in any development of policy and management, there is an initiation phase, identifies the problems, sets the vision and objectives, designs the classification, and then is followed by a phase which identifies the ecosystem types, puts it in the context of usually the river basin, and does a screening and assessment of the quality of the ecosystem health of that river basin. The third phase is an assessment phase, which creates monitoring programs. It sets ecological targets and ecological status and evaluation and reporting. And the fourth phase is a response phase, where there is a design of what is the response to the monitoring, to the information that comes from the assessment of those water bodies, and that it enters into the next cycle. Within that cycle, we can clearly realize that there are management objectives, and to understand when the management objectives have not been achieved, we can design, and we do design, clear management functions and processes that check and establish those management functions. So in order to have functionality, the process of management needs adequate coordination, human capacity and reporting, so as to better learn from successes and from failures. And the process of learning and adapting is known as adaptive management. So management functions have some clear components of themselves. They are there to support policy making. They are there to provide and channel feedbacks among the key stakeholder groups. They manage all activity over the policy cycle, including monitoring and the analysis of those data and how those data feed back into that policy cycle. And they identify core challenges. Now, if we're thinking about freshwater and ecosystem health, we are also thinking about ecosystem dynamics and the functioning of those ecosystems and how those dynamics relate to the management objectives and the way policies, aspirations have been formulated. So in this slide, we focus in on those ecosystem dynamics and show how those ecosystem dynamics fit within a well-developed management processes. This comes from a paper by Kingsford et al. 2021, which we encourage you to read. It's open access and therefore freely available. And although it is about the management of wetlands, it has broad and wide applicability to all of the ecosystem states and the freshwater health that we are considering in this course. So understanding how the ecosystem works from box B guides the processes of box A and box C. None of this, however, is possible without fit-for-purpose monitoring. Analysis of data comes from that monitoring and the response for continual improvement based both on the ecosystem results but also on the governance and management structure from which those ecosystem dynamics assessments, the assessment of those ecosystem dynamics, is rooted in. It also illustrates where the ecosystem dynamics that you have learned about and ecosystem structure in some of the previous sessions fit within the broader management cycle. And very often that management cycle and that idea of how to connect the different dots, what is the systems thinking here, is encapsulated by the common drivers, pressure, state, impact, response model to support environmental assessment and decision making. So this model, which is now widely used and increasingly used globally, thinks initially about what are the driving forces. That could be, for example, global trade, market consumer demand. What pressures does that put on a particular ecosystem, and how do those pressures relate to the state of that ecosystem? And what is the impact on the functioning of that ecosystem and on the policy objectives which are determined for that particular ecosystem? The response can actually go back to the driving forces, but the response can also address individually the pressure, state, or the impact. So it's a very flexible model. that is increasingly used and which is able to separate some of the responses from some of the more difficult global issues related to ecosystem management. We've included in this slide the definitions, common definitions used for the driver, the pressure, the state, the impact and the response, and we have added a definition of reference state and a definition of stressor. Now sometimes there is some confusion among the different components, but overall this model has provided and is providing a very useful framework in order to assess freshwater health and to address and mitigate the problems that those systems face. Now that brings us to the end of this first part of the management and governance fundamental lectures. So it's time for a break. It's time to perhaps read the paper, think about some other components to do with this, and to rejoin this session in your own time, which will be the second part and will follow in the course structure. Okay, thanks very much.